Okay, today's experiment is basically continuing on the skills that you got from last lab. You're going to be solving some circuits using Kirchhoff's laws. So we've already talked about Kirchhoff's laws in class, and you're going to be applying them. So basic rules, try to get my spacing right. Basic rules is you need to make or identify all the essential nodes and make a Kirchhoff's current law equation from all but one of the essential nodes. Then you identify all of the meshes, that's the smallest loops you can make, to fill the circuit completely and make a Kirchhoff's voltage law equation for each mesh. When you're done, you should have a number of equations equal to the unknowns. Other things that you need to do, and so I'm going to go straight to, I've already gone through solving these in class. When you start, these are the two circuits you're going to be exploring. The first thing you need to do, they have marked where I1, I2, and I3 are. You need to decide what direction you think the current will be going through each one of them. And it's pretty obvious in the first circuit what direction the current is going through each resistor. In the second one, there's one resistor that you have to make a straight guess. That's fine. If you're wrong, you'll just get a negative value. When you make your measurements for voltage and current, you need to make sure that you are measuring consistent with your picture. So let's just talk about the measurements real quick. Let's say that you chose to say the currents are like, and I'll just put random current directions in, directions that may or may not make sense to you. So there I marked the directions for the 6 currents. Right, you marked them ways that make sense to you. I just chose random directions. Once you have them marked, go ahead and mark which side is positive and negative for each one. So for instance, with resistor 1, the way I've drawn my arrow, which side is positive? Resistor 1, the way I've drawn my arrow, which side is positive? The bottom of it, right? You need to be clear on that. And so for each one, the tail of the arrow is the positive, the head of the arrow is the negative. Look at current 6 doesn't go through any resistor, but there's still a current going through that power supply. So I have all of my currents marked. Which side's positive and negative? I'm actually going to move these to this side to be consistent. Then you're going to identify each of your essential nodes and make a Kirchhoff's current law equation for them. So essential nodes, how many essential nodes are in this circuit? There are 4. The essential nodes are, there's one essential node, there's a second, there's a third, and there's the fourth. So you have 4 essential nodes. So you're going to choose 3 of those nodes and do a Kirchhoff's current law equation for the node. So remember, sum of the currents is 0, or sum in equals sum out. It's up to you how you do it. So you're going to have 3 equations that come from nodes. Then you have to identify how many meshes do you have. How many meshes are in this circuit? 3. So just choose those meshes. Label them, of course. There I've labeled my meshes and my nodes. And you're going to make a Kirchhoff's voltage law equation for each mesh. So through each resistor, the voltage is IR, and you get your signs by looking at, did I go from positive to negative? If I went from positive to negative, then it was a drop, so it's a minus sign. If you went from negative to positive, it was a rise, so it's a positive sign. So you're going to have a total of 6 equations. You have to have the same number of independent equations as you have unknowns. So 6 unknowns, I1 through I6, 6 equations. Then you have to solve those 6 equations. And I recommend you do it with the linear algebra. To that end, if you go to the spreadsheet that's in the Physics 151 folder in the computers, you have a spreadsheet that allows you to put in numbers. There's actually two spreadsheets on the Kirchhoff's law tab or worksheet. One of them is a 3x3, so you put your values in for each equation, and then it tells you the currents in milliamps. The other one is a 6x6, for the obvious reason of the one that has 6 unknowns. You put in your numbers, and it tells you what the currents are in milliamps again. So the spreadsheet is there to make life easier, so you don't have to make a 6x6 matrix on your calculator. Now, to remind us, you all made current and voltage measurements last week. But when you make a current measurement, what do you have to do? First thing to make a current measurement is to break the circuit. You have to make sure you break the circuit where you want to measure the current. So if I want to measure the current through resistor 1, where do I need to break my circuit? There are 2 legitimate places and a whole lot of wrong places. Okay, not take a resistor out, but take one end of resistor 1 out. So I would either pull this end of resistor 1 out or this end of resistor 1 out. So I'm going to pull one end of the resistor out, leave the other end in place. Do not make a mistake of, and many people have done this, they want to measure the current through resistor 3, and they say, well, this green spot here is at node B, and they'll just break the circuit there. But that's on the resistor 1 side of node B. You're going to be measuring the current through node B if you break it there. So you need to break it, pull one side of the resistor you want to measure out. And then if your arrow is pointing the way mine is, you need to have your wires. So you have on here, remember, current is this one here. And you need to have the current going into plus and coming out of minus. So if I broke it right here, then I'm going to have going from where I broke it, so going from node B, will go to the positive on my current, and then going from the negative on my current, I will come back to the resistor. If you put it in the wrong order, what's going to happen? You'll measure something different. You'll measure the wrong sign. Instead of positive, it'll be negative, or instead of negative, it'll be positive. Well, it makes a difference if it's positive or negative. So you need to be careful and put these in right. Similarly, if I'm going to measure the voltage, these are the voltage probes here. What do you do when you measure the voltage? How's voltage measured? Well, that's calculated, but how's it measured? With a meter. How'd you do it last week? What did you do to your circuit when you measured the voltage? A little embarrassing. You did nothing to your circuit when you measured the voltage. You left the circuit as is, and you put the voltmeter in parallel with the item you want to measure the voltage across. And once again, you need to make sure that you have the red going to the side that you marked as positive. So no matter what it reads, you're putting the red on the one that you said is positive, the black on the one that you said is negative. Okay. I'm not safe with that thing. You're going to put the red on the positive side, the black on the negative, and you'll record the value. If it measures positive, you put in a positive voltage. If it measures negative, you put in a negative voltage. because you are going to measure the voltages based on the current directions you wrote. And then you're going to calculate the voltages based on the current or the directions you wrote. Well, you're going to calculate the currents based on the directions you wrote. So you need to make sure that you're consistent. Notice there's I6. It's not going through a resistor. How are you going to measure I6? Go ahead. Yeah. You do just like you would with the resistor. You have the direction the current's going. You disconnect either the positive side or the negative side of the power supply, and you put your current measuring device in series. Do not put your current measuring device in parallel with the power supply. What will that do? Yeah, it'll blow the fuse in the meter. So don't do that. At this point, I assume that you know how to make these measurements because last week we went through and carefully set things up. So for the actual experiment, here's what you need to do. You need to come up here and you need to grab 5 resistors. Make sure you choose a resistor from 5 different places in here so they all should have different color codes. Name them R1 through R5. Write down the color codes for R1 through R5. Use a multimeter. There's 4 multimeters in here to measure the resistance for each one of those resistors. I've forgotten if it asks you to calculate the resistance value based on the color codes or not. It does? Okay, so then do that. Calculate what the resistance is based on the color codes. Measure it. And so you'll have 2 values for the resistance, the measured one that you have more confidence in and the nominal one. Then you're going to make circuit 1. So you actually make circuit 1, and you're going to measure the current. Each of the 3 currents indicated there, I1, I2, and I3. And the voltages, each of the voltages, E1, R1, R2, or the voltage E1, the voltage across R1, the voltage across R2, the voltage across R3. Make sure you're consistent with your picture and how you measure. And then you measure each of the, did I already say currents? I think I did. So you measure the voltages and the currents. Don't destroy your circuit yet. Do your calculation for what the values should have been and compare them. If you have the same values calculated, I mean, it should be within 5%. Same calculated values as you measured, then go ahead and destroy the circuit and move on. If they're different, then, raise your hand, call me, and we'll spend some time trying to figure out where things went wrong and try to get it correct. After you have those 2 correct, then move on to the second circuit. Make that circuit. I strongly recommend that when you make that circuit, you make that circuit so it looks like that up there. Right? You can make circuits a lot of different orientations, but if it looks like that, then it's easy to remember. Oh yes, this is resistor 1. I measured the current through resistor 1, so it's this end I'm pulling out. If it looks like that. So breadboards, part of the beauty is you can make your circuit so it looks just like that. So measure the voltages, 6 voltages. Measure the 6, 1, 2, 3, 4, 5, 6. Yep. 6 voltages. Measure the currents. Once again, 6 currents. And then make your equations and calculate what the voltages and currents should be. And make sure those agree. If those agree, then you're done. Question?
So when it says there's 6 resistors, it's supposed to be just 5 then, and we don't have, or is it the other one can be used or something?
There are 5. Does it say 6?
Yes.
Yeah. You only need 5 resistors. Okay. Remember, this time there is no observation, hypothesis, or test section. It's just the things that are laid out. And yeah, let's go ahead and once again have one group of 3, but let's say make sure we rotate around so we don't have the same group of 3s we had last time. Okay.